In this video, I'm going to talk about another BGP extended community. We call it SoO, or Site of Origin. What is the site of origin and what is the usage of the site of origin and how we can configure site of origin. This scenario is exactly the same scenario that we learned about that in the previous video, and here again we have the same scenario, and also we have the another race condition. You know that in the previous video I talked about a race condition, and we solved that race condition with the cast community. Cast community can solve the race condition without any configuration from the administrator. You learned about this in the previous video, but in this video I'm going to show you another kind of race condition and how we can solve that race condition with the SoO, or site of origin. First, we need to understand the problem, the race condition, and after that we can talk about the site of origin. Let me first define this scenario. Here again we have one service provider. This is our service provider. R1 is the PE1, means provider edge 1, okay, and also R4 is another PE4, okay. And also we have two core routers. We call them P router, or provider router, P2, and also P3, exactly same as the previous scenario. And also here, as you can see in R5, we have one customer edge, customer or CE5, this is the R5, and then CE6. Here we have only one customer with two sites. The first site, the left side, has one CE, and also the right side, where in the right side we have one CE, the CE6, okay? You know that we are using the backdoor link for only the times that the MPLS layer 3 link failed. This means that in this scenario, we are using by the MPLS VPN link with the highest priority. The first link, the primary link for communication between two sites, is the MPLS, okay, layer 3 VPN link, and also the second link or secondary link, okay, secondary pass, is the pass from the backdoor. Okay, here we have one backdoor, and in most cases the backdoor bandwidth is less than the MPLS layer 3, for example, bandwidth. Here you can see the bandwidth of this link is 1 megabit per second. Okay, because of that, normally when we are sending traffic from net A, this is net A and this is net B, okay, normally when we are sending the net A, or from net A to net B, we expect that this traffic should be forwarded from the MPLS VPN. But if the MPLS VPN link failed, we can use the backdoor link. This is the desired condition. Look at here. This traffic should forward to the R1, and after that it can label and send to the router 2, okay, and then we expect to router 2 swap the label and forward to the R3, and after that R3 can forward this again with popping first label to the or top label to the R4, and then R4 should remove the VPN label and forward the packet to the for example R6, and finally R6 can forward the traffic to the for example C2, the PC2. Okay, this is the normal behavior that we expect. I configured this scenario before, and now we can check the normal behavior. Look at here, this is the C1, this is the C1, and I'm using ping 192.168.610.610 is the IP address of the C2, and look at here, here is the network of 192.168.50/24, and here is the 192.168.60/24. Let me to show you the ping result. We will have connectivity. Yes, we have connectivity, and we can use traceroute command to find the path. and we expect to see the path from the MPLS VPN. Trace 192.168.610 from the PC1. The traffic goes to the router 5 and then router 1, then router 2, 3, 4, 6, and 10. This means that we are using the MPLS VPN. If the link between the R5 and R1, for example, fail, or the MPLS VPN fail, we can use the backdoor link. Okay, let me to show you here in the R5. If you check show IP interface brief, you can see these links. The link between R1 and R5 is fast Ethernet 01. Let me to shut down this interface, fast Ethernet 01, then shut down also in the router 6, for example. In router 6, we can use again conft interface fast Ethernet 01 and then shut down. This means that now we don't have the MPLS backbone. After that, again, we can use trace command. The traffic goes from the backdoor link 5610. Okay, 5610. Let me to enable the interface fast Ethernet 01 again, no shutdown, and then in router 5, no shutdown. Also, after some second, we will have again this path. Let me first ensuring this trace 192.168.610. Now we are using the MPLS VPN. This is the normal behavior. Okay. But in some cases, we encounter with the race condition. Let me to show you. Look at here. You know that when one address fail or remove in EIGRP, we need to advertise the withdraw message or the failed message to the other routers. For example, when net A failed, means the net A doesn't available now. Okay, let me to show you with another color. Now we don't have net A because this is failed. You know that every link, every addresses can be failed. Here the net A failed. Okay, because of that, we need to say to our neighbors that this link failed. For example, we can send the fail message to the router 6 and also router 1, our neighbors, because previously we learned them this update, this address, and now we need to say to router 1 and router 6 that this network does not available now. Because of that, let me to send to 192.168.50/24. This is the update for these networks, and this is failed now. This should be sent to the R6 and also to the R1. This is the first things that should happen when one of our links, okay, failed. In EIGRP, we are using in most cases the delay parameter, okay, to send the fail message to the other neighbors. I'm not going to delve to the detail of the advertising of the update of EIGRP, but you know that now R5 and R1 should remove the 192.168.50, the net A, from their topology table, EIGRP topology table, and also routing table. Also, you know that because R1 sent or advertised this update to the R4, also R1 needs to send this withdrawn message to the R4, and because of that, R4 can understand that this link is failed. Look at here, from the MPLS VPN backbone, we need to send this failed message to the R4, and because of that, R4 can understand that this network is not available, and this is the process. This is the normal process. We said to the R6 that this network does not available, and also to R1, and R1 said to R4. Now all of the routers, all of the for example routers in this company know about the failed address, and they should remove this address from the topology table and also routing table. But also we have another function in the EIGRP. You know that when in EIGRP one network address fail in one router, that router, after sending the failed message to other routers, try to find another path to the failed networks. For example, we are using the query message. Let me to show you the query message. This is the query for these networks. This means that when R5 doesn't have any path to the 192.168.50